Hello and welcome to Differential Discussions. I'm Melissa,
And I'm Dave.
and today we're starting leukemias. It's what everyone's been asking for.
Yeah, I just applauded leukemia. I don't know if that's a good look, but I did it. So
They are beautiful to look at.
Mm.
Not
That is-
beautiful for the patient, but they are beautiful for us to look at.
that's what we hear in the lab all the time, right? It's everyone's, oh my God, look at this. And it's like,
The more beautiful it is for us, the less good it is for the patient usually.
that's right. That tracks. It does track.
Yeah. So today we're going to start by looking at an AML that has blasts without maturation. So if we were thinking about the classification system, it would be under the WHO classification system of not otherwise specified, and it would be the old FAB M1.
Yep, absolutely. And I think Melissa's starting here on the 40x objective. And it's a good, it's good practice to kind of scan on lower powers. Generally with eyes and scope, I use 10 or 20, whatever is on the scope. But I think for the camera and for what we have here, this will serve as a pretty good proxy for that. But yeah, every slide.
With lighting too much.
What's that? Sorry.
I don't have to fight with the lighting too much.
Yeah.
If we start on 30,
yeah.
and go to 100. If I start on 10, then it's like, I'm going to blind everyone.
Yeah, getting this to technically work well and making adjustments takes a lot of finessing that Melissa has put a lot of work in too. But yeah, so scanning on low power allows you to kind of see patterns, and I wouldn't do morphology here, but being somewhat experienced morphologists, we can kind of see that these big mononuclear, I should say, cells are suspicious, right? They catch your eye.
Yeah. And I think the other thing you notice is that there's a lot of them, and you'll see more as we kind of scan around and move. I'm staying here because I want to talk about a particular pair of cells, but in general, when you look at these malignancies, because you're looking at this clonal expansion of a malignant cell, you're seeing lots of the same looking-ish cell a lot of times. Not every time, but a lot of times.
I have in my ear, I can hear a friend saying, birds of a feather flock together, the old saying. Yeah. So you get a pair of cells you want to talk about. Which pair would that be?
Right here. So you on scan, you'll see this a lot in malignancies where the white cells are touching one another. That's called a loss of contact inhibition, because usually the different white cells repel each other. They don't want to squish together. They don't want to touch one another. But when you're malignant, you lose that inhibition and you kind of gather together and bunch up. So it's much more common in malignancy than it is anything else. And I think we've looked at some pretty cellular slides, and you don't usually see the white cells bunching up like this unless it's a malignancy.
Yep, that's a good point. And so these are one of those things when I do my low power scan and I see, a pair touching, a group of 3 or 4, highly unusual.
Yep.
Highly unusual to see that. So that's kind of a red flag.
Yeah. And it's not something you note or something like you write down or something you report. It's more of a mental note for you because you just know that's characteristic of malignancies in general.
Right. That's a good point.
So let me move around a little bit so we can scan and just see.
Sure. And although they're quite small at this magnification, I can kind of see that the platelet count's probably low too. Again, I'm not doing formal things, just kind of gathering data for my eventual oil assessment. This is a great slide.
So very cellular.
Mm-hmm.
If we were doing a white cell estimate, this would be a higher white cell count.
Mm-hmm. I'm also noting I'm seeing smudge cells.
Yep. Not an overabundance of them, like you would expect in certain malignancies, but they're there.
Yeah.
All right, you want to drop down?
Let's do it. Yeah, please. Oh, awesome field. You're too good at this. um, yeah, so a few notable cells. We'll start with the easy one, center field. We have a nice neutrophil hanging out. And then we have two high NC ratio, nucleus to cytoplasm ratio cells. And one of them has something in the cytoplasm that's very diagnostic. Is diagnostic the right word, Melissa? Could we say diagnostic? Or it's at least indicative of a acute myelocytic leukemia.
Maybe
And
pathognomonic.
oh, my vocabulary grows hanging around you. Pathognomonic. So when we see an Auer rod, so what Melissa highlighted here, when you see an Auer rod,
This
it's
guy,
almost certainly a myeloblast. Yep. And generally they have this beautiful pink color. It's essentially the primary granules that you would see in something like a promyelocyte fused together, and they form these it's almost like a splinter, very similar to a gout crystal in kind of its appearance, for those that know what that is and relevant, but super cool.
Yep. Yeah, absolutely. And so when you see Auer rods, they are present. It's generally a present. It's not generally a count. It's not a quantitative thing. It's usually a qualitative thing when you see them. And generally, you're only going to see Auer rods in the myeloblasts and promyelocytes.
Mm-hmm. Mm-hmm.
Occasionally, you can see them in monoblasts, and they really are specific for the myeloid lineage, because in general, lymphoid lineage does not have Auer rods. Although I have read in the literature one case of it.
Fascinating. Wow.
But that's the only one I've ever heard of. And so when you think Auer rods, you should think myeloid.
Right. And including this information to the clinician, might get them to kind of narrow down treatments and kind of get working on a patient sooner. Then the flow data may be available sooner than the cytogenetics and things may be available.
Yeah, well, and I think too, I don't know flow as well, and I've never worked in flow, but I think it could also help figure out which flow panels you should be doing.
Excellent point.
So rather than doing like the whole gamut to screen, is it lymphoid, is it myeloid, and then going more specific, you already know it's myeloid, so you can go right to those panels.
That's a good point. Yeah, we're both not flow techs, but certainly the more broad your search is, the more times you're going to have to do specific panels to kind of narrow down. Yep. So yeah, that's a good point. Just cut out the lymphoid markers.
Yeah. All right. So we have a blast with an Auer rod, and then just a blast.
And then, yep, just a plain old blast.
Just a blast. Just a blast. But these blasts these two blasts are interesting. The chromatin is very soft. Yes. It really makes me think of velvet when I look at it. And it's nice and even. And these cells have a little bit more cytoplasm, though, for myeloblasts. When we think of blasts, we think of not quite scanty as ALL blast cytoplasm, but we usually think of less. And these guys have more cytoplasm. So that varies with patients.
Yeah, if you ever see a cell that's large in size like this, so like we have a neutrophil in the field, which is convenient. And these cells are bigger than the neutrophil. And if you have a cell that size where you can barely see any cytoplasm, that is a very strong indicator of some kind of a malignant blast form or something. So Melissa's right. This one has a little bit more cytoplasm than we might expect. I'm also kind of scanning the fields, and I'm kind of confirming that we have a very low platelet count too, right? So, typically with acute leukemias like this at presentation, you're going to have all 3 cell lines probably affected in some way or shape or form. So having the absence of platelets, maybe a low H&H, and then either an elevated or a low white count. Those kind of help you, have more confidence in your blast call, I'll say.
Yes. And the severity of the anemia and thrombocytopenia are generally more pronounced than in a chronic. leukemia, unless somebody has waited until they're like really far into the chronic leukemia to come in, and
Sure.
then they might present similarly. But usually chronics you either find early on accidentally, or because you're looking for something else and you find that. But usually you find it earlier and you notice that the patient may be slightly anemic, maybe thrombocytopenic, slightly depending on the chronic leukemia and again where you are finding it. But usually when you're talking about an acute, it's anemia and thrombocytopenia.
Right.
No questions asked. And then, like Dave said, the white cell count's variable. It could be increased, decreased, or normal. And it's just the cells that are not normal.
Right. Right. Cool. That's a good field.
Good place to start.
Awesome. So that center cell there, lots of, I don't even know how to start to describe how weird it looks, how abnormal it looks. Yeah.
Yeah.
Is the nucleus, the way it's kind of, even the variation in color and the chromatin, that's extremely unusual to have. There's a term for it too, right? But just variable staining of the nucleus, unusual.
It's almost more of a dysplastic feature.
Yeah, true. Which there can be some overlap here, right? With Luke's. Yeah, that cell's extremely abnormal. When I'm already in a frame of mind that we have blast present, this is just going automatically into the blast category. I generally am of a mind, and it's my habit that once I know this malignancy, you have to prove to me you're a normal cell. That's kind of where the burden of proof will then kind of shift for me personally.
Now they are guilty until proven innocent.
Yeah. And then the cell in the, oh yeah, sorry.
No, it's fine. Yeah, no, so that definitely malignant looking, and it, like you were saying, it looks different. It looks weird, but it still has similar features to the cell that we have over here and to the cells we looked at before. So like you said earlier, birds of a feather, let your friends around kind of help. So the other cells are telling you, wow, they have these same features as this cell. So if it walks like a duck, if it quacks like a duck, it's a duck. So it's a blast.
That cell's interesting too on the left, right? So
this one's beautiful. It's got
pretty
a nucleoli here, here. Oh, and of course it took my little marker away. Here. And it looks like there might be another one over here.
Yeah.
A little bit harder to see. There it is.
Yep, that's right. Yep.
And it even has a vacuole.
Yeah. Yeah, I mean, like one nucleoli in a normal cell, maybe two, I guess. Yeah. You get over two and it's just, that's not normal. It's very, very abnormal. Yeah. Yeah. Lock that one in for a blast.
And then there's a couple other nice ones right below.
Oh, cool. Is there more Auer rods in this one too? This is multiple Auer rods? Or?
That looks like granules.
Okay, my bad.
No, that one's easy to mix up because when you're looking on this side, those are just a couple of granules.
Yep.
So they look almost Auer roddy, but then all the granules are actually on the nucleus and a little bit over here.
Cool. Okay. Yeah, and there's some like striations in the nuclear chromatin too, where I thought maybe Auer rod might be in there, but I'm mistaken. So we have some degree of maturation in this cell, it looks like.
Yeah, it looks like a promyelocyte with all those primary granules. Okay.
And then its buddy on the right. Looks like there's a couple of nucleoli in there. And
yep. And I wonder if there's an Auer rod right there, really thin.
Difficult for me to make out personally, but
yeah, that one is hard to make out. The other one was easy.
Yeah. So we might go promyelocyte and then a blast here.
Yeah.
Yeah.
So promyelocyte and then blast. All right. Well, let me just pull the other one into the field.
Sure. Oh, I might need your help with one of these cells.
Okay, so we'll start with that one.
Sure. Yeah, I mean,
Start with the easy one.
and then thinking about what we've seen on the slide here, we got these velvety kind of chromatin pattern. Looks like a couple of nucleoli in there, maybe.
Yep.
That pretty consistent with the blast forms we've seen.
Yep.
And then, yeah,
Creature.
I want to use your expertise for this one. Let's go.
So it's got orange granules.
Pretty.
So I'm wondering if this is an immature eosinophil.
Awesome.
It
That's so
doesn't
cool.
look like a mature eosinophil.
Right. And why not? What would
The nucleus is too big.
Yep.
And it's monolobed.
Right. Yep. So typically the EO will be a bilobed, right? But EOs grow up. EOs have younger versions of themselves. And EOs and Bezos tend to show up in malignancies and some myeloproliferative disorders, right? I don't necessarily know the exact association why they're there, but they're there. So really, really cool.
It usually depends on where the issue, where the mutation, where the damage is in the whole maturation sequence. Because if you're dealing with a granulocyte progenitor cell, meaning it hasn't yet committed to a specific lineage, it's just going to be a granulocyte. And if the damage is there, then all three of your lineages can be impacted. But if it's specifically a neutrophilic progenitor cell that has been impacted, then it's really only going to be at that particular lineage. So what other lineages are involved always depends on where the damage was up the maturation sequence.
It's an excellent insight. Yeah. So what was that? The gem, right? The gem colony.
So that's even higher.
That's higher up the food chain.
Yeah. Yep. So that's the common myeloid progenitor is the gem one. The gem is just granulocyte, erythrocyte, monocytic, and megakaryocytic.
It's basically everything but the lymph, right?
Yeah. So that's why we just call it the common myeloid one.
Yeah.
And then when you go down from there, then you have, granulocyte, monocyte progenitor cell. And then you go down to a granulocyte progenitor cell. And then from there, you go down to particular lineages. So it just depends on which of those progenitors has the damage.
Leukopoiesis.
Stem cell theory. Everybody must know it.
Yeah. Obviously, I have a surface level understanding of it.
Okay. But yeah, that looks like an immature eosinophil.
Yeah, that's cool.
And even the chromatin isn't like as clumped as you'd expect an EO to have. So it's even immature in the chromatin.
Right. Yep. Pretty cool.
And then right there is just a neutrophil.
Yep.
Keep going.
Cool. So we have a smudge on the right hand side.
Yep.
And then this cell is interesting. So that looks like another Auer rod. Am I mistaken here? Yeah. Cool. So we have an Auer rod in there.
Right here.
And then some other features of the chromatin pattern, those little like holes, sort of. Those are, not necessarily a normal thing to see.
Yeah. I feel like those holes contribute to almost how the chromatin pattern looks almost like static TV.
Yeah. Yep.
I don't know if kids these days know what static TV is.
So the snow, right? The snow on the TV. They've probably seen it in a movie or something. Right?
That's true. They've probably seen it in a movie, but we used to see static because, Dave and I are old now. So we used to see static. And so it just sometimes because sometimes those white dots are really prominent in the nucleoli.
Yep.
And when you see that, I really think of static TV, just like purple and white rather than the gray and white, which you actually see on TV.
Right. That's cool insight, actually. Yeah.
And actually, before we move on, we should just say smudge cells. So this is a smudge cell. Like we said, it's a smudge. Smudgies were cells in the blood. And then when you made the peripheral blood smear, you smudged the cell. So these smudge cells were cells, and they were probably, well, not this one, but the whole cells are counted by the analyzer, and then we just smudge them because they're fragile. So during the smearing process, they're smudged.
Another one.
Yep. Yeah, another smudge. And then this looks like a weird looking neutrophil.
Mm-hmm.
Like the cytoplasm is way less pinky lavender than you would expect.
Yep.
It's
looks a little beat up too, right? Like
yeah. I feel like the cytoplasm almost looks mono-esque.
Mm-hmm.
The nuclear chromatin pattern is definitely more neutrophil, but the coloration is just like.
And these cells likely grew up in a really hostile bone marrow environment, right? So they can either have direct effects from whatever the malignancy was, or just a bad neighborhood.
Mm-hmm. Yeah.
Oh, awesome.
Let me pull him in.
So another great blast here on the bottom. I think the thing I like about it most was, oh, sorry. Yeah.
No, not you. I'm growling at the thing. Go ahead. You can talk about it.
The thing I like most about the cell in the bottom right-hand corner here is the nucleus has a weird shape, right? So like generally the nucleus is round-ish, but then you have these weird contours, to me, usually suggestive of malignancy. Obviously, we're very many blasts deep, so it's an easy call in the context, but in a vacuum looking at it, it looks pretty malignant to me, given that contour and other features, obviously, too.
Yep. Yeah. And he's kind of squished.
He's a squish guy. He is a squish guy.
But he shares the features that we've been discussing.
Mm-hmm. Yeah, absolutely. Yep. Blast. The cytoplasm looks a little on the lighter side, but that's fine. And there's something big and scary and blue at the top.
Right up top, I want to pull it in.
Yeah. Okay. So this
is that a reactive lymph?
I don't think so. I'm scared. So I think this is just an uneven, weird staining in the cytoplasm of the cell. Can you have reactive lymphs in a leukemia? Absolutely, you can see reactive lymphs. What are your thoughts, Melissa, on this cell?
Oh yeah, no, I think it's a blast.
Yeah, okay.
It's just a dark blue.
Yeah.
That we're used to when we've talked about reactive lymphocytes.
Sure.
No, I just think it's just a blast.
Yeah.
Chromatin pattern says more blasty, although you do have a couple of darker spots in there, but it still otherwise just kind of looks staticky.
Yep.
Just like a blast. And also it doesn't, outside of that one deep dark blue area, it doesn't have other characteristics of a reactive lymphocyte.
The stretching.
Yeah. And like you said, you can see reactive lymphs, but you're not going to see them often.
Right.
So more than likely, if you're seeing something else weird, it's probably part of the party.
Mm-hmm. Yeah.
So it's probably a blast, but
yeah. So again, this is where my little heuristic Dave tech hack, and so the other, I think a lot of students and maybe young technologists are so concerned with getting every single cell absolutely correct, and I admire that, and I certainly want to be as right as I can about this stuff, but in reality, if you make a bogus call on a handful of cells, it's really not going to matter. The main thing here, right, is they have AML. You know, and other things that are very important in our assessment for this too, because we've been focusing a lot on the white cell morphology, but getting that platelet estimate accurate, right? Letting them know what's going on with the red cells. That information is really, really important too. That's harder to ascertain maybe in other parts of the testing. But, you know, if you have a goofy cell that's a little confusing, I say default it to blasts. If you think in your heart of hearts that this is a reactive lymph and you call it as such, you're not going to kill the person.
Yep. And you could always ask someone.
Absolutely. You know, 2 minds better than 1, 3 better than 1, etc.
You know, in school, it's very assessment. You have to identify this cell. But when we're working in the lab, it's like, hey, can you roll over here and take a look at this cell? Mm-hmm. We do a lot of that in the real clinical labs. Yep,
absolutely. I really think that is such an important part of getting the right answer in a lot of different aspects of the heme lab. And yeah, and you know, with students, it's tough because we're trying to individually assess. I want you competent by yourself.
Yep.
We want to straddle that line of letting you guys work a bit together and learn from each other, but you need to be able to function on your own, right?
Yep.
It's tricky.
Yeah.
Cool. This is a scary cell. Hey! Blast. This is a blast. So inevitably, whenever whenever techs start learning AMLs, lymphs turn into blasts. Happens all the time.
Yep.
But yeah, what do you think, Melissa?
It's a lymph.
It is a lymph. It's a pretty little lymph just hanging around.
His nucleus is about the size of the red cells around him. He's much smaller. Yep. There's a lot of dark chromatin in there, which we haven't been seeing with our blasts.
Right. Yep. So lymphs are still around sometimes.
Yeah, the normal adult cells can still exist.
Yeah.
Speak of the devils.
Hey, cool. So we got 2 lymphs here.
Yep.
That's awesome.
Yep. The other thing is they're different morphologically as well.
They sure are. Yeah, that's
Very
a good
different.
Point.
Yep. And that just kind of throws back to, and when we talked about normal WBCs, we talked about how there's such a variation of lymphs. Still a variation of the lymphs.
Yep. They all have different jobs and functions. Okay, so we're back to blast lands.
Yes.
So this one, the one in the middle here is the smaller blast, but still very much a blast like its buddies.
It's still large compared to the red cells.
True, right. Yeah, true. That's a good point. So yeah, this is keeping in mind visual anchors. You know, we had that lymph down there. We were comparing it to the red cells around it. Let's continue that function. Yeah. And
yep. 3 blasts. And then let's talk about that one.
Yep. Yeah.
So we've got nucleoli. It looks like 2 nucleoli kind of smudged in together right there. There might be another one here.
Yep.
Nucleoliville.
And then in the top right, we see more of that really dark blue weird cytoplasm, and it's not consistent throughout the whole cell.
Yep.
So, you know, maybe you might have been a little skeptical about the call in previous fields that scared you. And then maybe this cell reassures you like, okay, wait, yeah, this is just how some of the blasts are appearing.
Yeah, especially where this one, like the nucleus is clearly blasty.
Yes.
Same chromatin pattern, nucleoli, just that weird dark blue cytoplasm.
Yep. Cool. Yep, another blast.
And I think he's got an Auer rod right there.
Oh, cool. Hard for me to see, but he does have googly eye.
Here, he's got a big one. Got a big one here. Looks like he's got another one over here. At least. Yep.
Yeah, looking at cells is a lot like looking at clouds. You start to see like faces and other weird stuff. Oh, blasts.
Yeah, and again, we're seeing some of the dark blue.
Yeah, good point. Good point.
And
Yep.
this guy's got a couple of Auer rods right there.
Oh, cool. Yeah, very, very cool. Yeah, this is a great teaching slide.
I love this slide.
And Auer rods may not be around in an AML. They might not be there. If you see them, call them. If you don't, we have another limb.
I think I can get these guys together. No.
Cool.
Come back.
Yep. Oh yeah, trying to get them both in the field.
Yeah.
There you go.
Yes.
And we can see the chromatin patterns here juxtaposed. We can see the lymph is much more clumped, much darker.
Much smaller.
Yep, much smaller.
Very small amount of cytoplasm compared to these guys.
Yep.
I was looking to see if I see Auer rods, but I don't see Auer rods. And then just a quick comment that the nuclei are very large and rectangular, but they don't look stretched like a reactive lymph does. They just look rectangular.
Right.
Sorry, I keep elbowing.
That's okay.
All right, let's move and do maybe one more field.
Sure.
That's a good one.
Yeah. And again, a couple more blasts.
A couple more blasts, and this one's got a really nice nuclei. I mean, Auer rod.
Yeah. Yeah, it looks like we have like these two styles of blasts present now with these dark blue cytoplasm and then these other dark blue.
Yeah, and that's a good point because sometimes that's indicative of different populations of blasts.
Right.
And then sometimes it's just the same population, just slightly different looking.
Yep.
That depends on the patient. When you'll find out that information from flow.
Right. Yes. 100%.
Okay. Well, I think that's all we've got for this slide for today. So thanks for watching.
Yeah. Thank you for your time.
Please like, subscribe, and hit the bell if you'd like notifications whenever we post a new video. And feel free to reach out to us on social media or via email with comments or suggestions about future content. Thanks.